All right, so some more U substitution rules. I'm going to do number 10 on the page next. And that problem is the integral from 0 to pi over 4 of tangent squared of x times the secant squared of x. Now this problem I could see being a rather difficult one because we know some facts about tangent and secant going together. For example, I'm going to write out some facts here. You know that the derivative of tangent is equal to secant squared. You know that the derivative of secant is equal to tangent times secant. And we see elements of both of these. And you also know you could do some trig identities to these. We could call this the sine squared of x over the cosine squared of x times 1 over the cosine squared of x. And we could try to use that trig identity before we jump into the integral. So it's going to take some sophistication and some practice to really identify which of these things you want to use. The first one that I listed, I'll tell you, is the one that's going to be preferable. What I see here is if I set u equal to the tangent of x, and just the tangent, not the tangent squared, because again you'd have to use a chain rule if you decided to use the tangent squared, my du would be equal to the secant squared of x dx. And that means that in this problem, I have the integral. Again, I'm not going to put my bounds because I like to wait until the end to put those in, and I don't want to confuse myself about what variable they go with. I have my integral of u squared, and the whole rest of this will disappear because it's part of my du term. And it goes to something very, very simple, something that's with the basic rule. And so you're going to take your u, add 1 to the power, multiply by 1 over that power, change this to, change this to back into the x's, which means that now we have tangent to the third of x. And now I can worry about what this looks like when I plug in my bounds. So I have 1/3 times the tangent cubed of pi over 4 minus, let's see, that looks like it's a 3 times pi. Put parentheses around that. Minus the tangent cubed of 0. And from the unit circle, we know that the tangent of pi over 4 is equal to 1. 1 cubed is equal to 1. And the tangent of 0 is equal to 0. 0 cubed is equal to 0. So this simplifies down to just a simple 1/3. I'll do, let's see, problem number 15. Another u substitution. This one's going to be algebraic. And again, it's going to be a definite integral going from -1 to 1 of 2x over 4 plus x squared all squared. Because we've got fractions we're dealing with here, again, u substitution is going to be preferred. Set u equal to the thing that's in the parentheses and on the bottom of the fraction. That's usually what both of those are what you'll set u equal to anytime it's in parentheses, and especially if it's at the bottom of a fraction. My integral here, or my derivative is 2x dx. In this case, one of those rare instances where we don't have to divide the constant to the other side. I now have a problem of 1 over u squared du, which I should write that in my power form before I take the integral. Less likely to make mistakes if I do. I add 1 to the power. I multiply by 1 over that power out front. This will give me the same thing as 1 over, I'm going to put my negative upstairs, and I'm going to go ahead and put my u term back into the problem, 4 plus x squared, all to 1 power. And then now I'll deal with my bounds. So I have 1 over 4 plus 1 squared minus the negative 1 over 4 plus negative 1 squared. These will cancel. In both of these cases, we're going to get 1 over 5, but this one will be negative 1 over 5. This will be positive 1 over 5. In this case, they're going to equal 0.